Okay, in this video we're going to have a little look at the Ohm's law experiment and just what's going on with the components in that circuit. And to do this we'll just build a simulated version of that same circuit. So this is the circuit construction kit from FET, and you should all have access to this through our Ammeter site. Otherwise you can just Google PHET and circuits or something like that. Okay, so the first thing we're going to do is take a battery, and then we'll put a switch next to the battery so that we can turn the battery on and off. So this is a bit like the power pack that we use in class. Then we'll take a wire to connect to the battery, and another wire, and then we'll add an ammeter by ticking this little ammeter box on the right hand side under Tools. Then we'll put the ammeter into the circuit. We'll take another wire, and then we'll put a resistor into the circuit, and another wire, and there's our circuit. Notice that there's nothing happening in the circuit at the moment because the switch is open. As soon as we close the switch, you'll notice that the little blue objects will start to move in a clockwise direction. The little blue objects represent electrons in this circuit, and the black end of the battery is the positive end and the gray end is the negative end. And we have electrons being pushed away from the gray end and being pulled into the black end of the battery. And what the battery is doing is it is a voltage source. It is pushing the electrons around the circuit, and the electrons can't overtake each other. They're a little bit like a train in that the one electron can't move unless the one in front is also moving, and we're giving a push here which causes all of the electrons in the whole circuit to move at the same time, because they're all, you can imagine them as being connected a little bit like a train. If we open the switch, the electrons stop moving, because basically it has become impossible for electrons to move through this little bit of the circuit. So no matter how hard we push here, we can't make any electrons move because they can't move past there. So no matter how hard we push at the negative terminal of the battery, the gray end of the battery, they can't get through the switch because it's an opening in the circuit. Okay, once again, we'll close it. So the battery acts as a push. The resistor in the circuit acts as a place where the electrons are slowed down. So we can imagine it being difficult to get through the resistor, which means because it's very slow getting through the resistor, it means that all of the electrons behind the resistor will be slowed down, and the electrons in front will be slowed down too, because the electrons in the resistor are slowed down. So the first thing we can do is just see what happens when we increase the voltage. So let's increase the size of the push here from 9 volts to, let's make it, let's double it, 18 volts. And you should be able to see that the electrons are now moving faster. So because we're pushing the electrons harder in the battery, so we're pulling them into the black end and out of the gray end with a bigger force, that means that the electrons all around the circuit are moving faster. The second thing that we can do to change how fast the electrons move is change the resistance. So if we put in a resistor that's easier for electrons to get through, so let's change the resistance. Instead of 10 ohms, let's make it 5. You can see that the electrons speed up even more. And the reason the electrons are speeding up is because it has now become much easier to move through the resistor, and the resistor is the only place where it's where the electrons are being slowed down. So because it's easier to get through the resistor, all of the electrons move much more quickly around the circuit. Now, this white box is an ammeter. that measures how many electrons are passing through it per second. And it measures it in a unit called amps. So the more electrons we have passing through there per second, the more amps of current we will get. And so let's reduce the voltage back to 9 volts. And we went down, we just halved the voltage, and you can see from the ammeter that the number of electrons passing through it per second has also halved. And so we have fewer electrons passing through the ammeter per second, which means we get less, which is a smaller current. Now, the next thing we can do is put a voltmeter into the circuit. And now it looks like the circuit that you're going to build for your experiment. So we plug in the voltmeter with the black lead into the negative side of the resistor, and the red lead into the positive side of the resistor. And you can see at the moment that we have 9 volts across the resistor. Okay, now by measuring the voltage across the resistor, what we're basically doing is measuring how many volts are lost there. You'll see that it's also 9 volts across the battery, and that's how much energy is gained in the battery as a result of the battery's push. 9 volts is the amount of energy that's lost in the resistor as a result of it slowing the electrons down. And so you can see here that all of the slowing down is happening in the resistor because we're losing exactly the same voltage that we gained in the battery. Alright, in the experiment that you're carrying out, what you're going to do is gradually increase the voltage from 2 volts to 12 volts. In fact, let's just fix the resistance because you're going to be using a 10 ohm resistor. And as you increase the voltage, you're going to measure how the current in amps changes in your ammeter. And so you will measure the voltage using the voltmeter, and you'll measure the current using the ammeter. And the voltage is your independent variable, the current is your dependent variable, and we will of course need to keep the resistance constant in order to carry out a fair test. If you have any questions about the ideas of voltage, current, or resistance, please post them to the forum or ask in class.